better practice quiz on simple harmonic motion springs here. Question says, a spring with a 50-gram mass on the end of it is stretched 10 centimeters with a force of 2 newtons, then it's let go, and then it vibrates in simple harmonic motion. Look, I just noticed the fact that I have this displacement in centimeters. I want to convert that to meters, so I'm just going to draw attention to that now. We want to find the spring constant, the maximum potential energy, the maximum kinetic energy, and the maximum speed. So just about everything here. Let's write down some givens here. We have a mass, oh, I should circle that as well. I have a mass of 50 grams. I'm going to convert that to kilograms, 0.050 kilograms, right? 50 divided by 1,000. It's stretched 10 centimeters. X is 0.10 meters. I convert the 10 centimeters to meters by dividing by 100. There's a force applied here of 2.00 newtons. It vibrates back and forth in simple harmonic motion. Look, let's deal with one question at a time here. We've got the spring constant, we're looking for the spring constant. So let's just say for this one, F is equal to Kx. Rearrange that. To solve for K, I get F over X. F is 2.00 newtons divided by the displacement of 0.10 meters, and that gives me, what is that, 20 newtons per meter, I think it is, right? Should be 20.0 newtons per meter. Good, there's question A. What's the maximum kinetic energy on the end of the spring? Sorry, what's the maximum potential energy on the end of the spring? Well, look, if it's stretched 0.1 meters, that's the most that it's stretched. Well, then that's going to be when there's the most potential energy, right? That's maximum displacement. So we're just going to say for this one, EP is equal to 1/2 kx squared. Let's say 1/2 k, we just found that, of 20 newtons per meter. The displacement is 0.10 meters. Let's square that. I'll do this one on the calculator here. 0.5 times 20 times 0.10 squared gives me a value of 0.100 joules. So there's the maximum potential energy. Now, when I let this go, the displacement is going to become less. As the displacement becomes less, the potential energy becomes less, and the kinetic energy becomes more. When is it at its maximum kinetic energy? Its maximum speed, its maximum kinetic energy? When there is no displacement. So let's find its maximum kinetic energy. Well, easy, right? When it's full displacement, its potential is 0.100 joules. When there's no displacement and all the potential has been converted to kinetic, then we're at maximum kinetic energy. The maximum kinetic energy is 0.100 joules. That's it, right? EI equals EF. The initial is potential, 0.1. The final is kinetic, 0.1. So let's say for question C, EK, the maximum kinetic energy is 0.100 joules. And then for the maximum speed, for that one, let's just say EK is equal to 1/2 mv squared. I'll rearrange this now. How do I rearrange this? Got to solve for V. Got to solve for V. I can divide by 1/2 m, right? Or what's the other thing that I can do? Anybody? Yep. Yes, I could multiply by 2 and then divide by m. Doesn't really matter what you do. EK over 1/2 m. Seems like most people like to do that. Now, solving for V, I got to square root that now, right? So let's say V is the square root of EK over 1/2 m. So what do we got here? 0.100 joules divided by 1/2 of 0.05. Make sure that in the bottom, when you're subbing your numbers into your calculator, that you're going to use brackets. And in fact, we should probably use big brackets there as well. So let's say square root brackets, 1 divided by inside brackets. Second function, square root big bracket divided by inside bracket, 0.5 times 0.05, and the inside bracket and the outside bracket, and it gives me 2.00 meters per second. Good. How do you feel about that? How many people got those numbers? Okay, good. Good.